Hello everyone, it's indeed inspiring to see you back again, and I welcome you all to the sessions of Apache Flink. If you want to define Apache Flink, what all things you need to consider? You need to consider the Kappa architecture, stateful computations, distributed computing engine, and bounded and unbounded data. Till now, whatever architectures we have been discussing, let it be Apache Hadoop, it is distributed. Let it be NoSQL databases like Cassandra or HBase, that is also distributed. Let it be Apache Spark, that is also distributed. And in fact, Apache Kafka is also distributed in nature. So the kind of architecture we have been exploring, they are actually distributed computing engines or distributed parallel processing engines. They are like that only. Okay, so we will discuss one by one each of them. So let us basically begin with the first one, which is basically trying to understand the whole of the ecosystem of Apache Flink. So here you can see that this is the whole ecosystem which I have tried to draw on here. First part we have is storage. So in case of storage, what all do we require? So in case of storage, I actually want that some sort of file systems are required. So local file system is there, HDFS is there, Amazon S3 is there. So these file systems, they help Apache Flink to give the storage support. Then in databases we have MongoDB, HBase is there. Even streaming frameworks like Kafka, Flume, and RabbitMQ, they help in the storage part. Second one we have is deploy. So for deployment, what do we require? So in order to deploy, we can have the deployment on local JVM. This is what we keep on doing for practice purpose. And the second option you have is you can have a standalone cluster, or you can build the real cluster, like multi-node cluster, with the help of Apache Yarn. That is another option you have. Then we have engine. Engine is a core library which basically makes the base of Apache Flink. So for engine, you can see that we have Flink's runtime that acts as an engine, and it helps for it to run. Otherwise, like we cannot run it. For example, like Hadoop has got Hadoop core, Spark has got Spark core components. So that is how Flink's runtime is the base engine which actually generates or runs everything. Then we have abstraction. This is very important. Like as a data engineer, or as a uh, analytical engineer, you actually need to work here. So you need to work on data set, that is batch processing. You need to work on data stream, that is stream processing. So these are the APIs, data set API and data stream API, using which you have to actually work. And once you are done with all these libraries, then what else is remaining? Then basically some other libraries are remaining, and these libraries are table library, jelly library, and Flink ML library. So these libraries are left out. Zeppelin is there, which visualizes your Flink related metrics. So all these libraries are again a helping hand in case of if we see the whole ecosystem, they help us a lot. Table API works with streaming and batch processing both. ML provides some machine learning capabilities to Flink. So this is the Flink ecosystem in a nutshell, that how Flink actually looks like. Now let us move ahead and try to understand more on it. So I am moving ahead, and let's have a discussion on how basically a job gets executed in Apache Flink. So we have a client which is responsible for compiling the job, and after compilation it submits the job to the job manager. So here you can see that we have client component, we have job manager, and then we have multiple task managers. So this is how the whole of the components in case of Apache Flink, they comes into picture. And after them we have the first step, as the job is submitted by the client. Then the job manager accepts that particular job. It deploys that job to the task manager. Task manager are responsible to actually execute the job, and after execution they basically give the status also to the job manager. Job manager is very much similar to the resource manager, where scheduler and application manager is there. Here basically you can see we have scheduling and resource management is there. So this is how it basically tries to complete the job. Task managers are also responsible for task execution as well as data exchange, because ultimately the task is uh, getting executed on the data sets only. Let us try to understand more about each of these terminologies, that what these terminologies actually mean. So So program is a piece of code that we want to run in the Flink cluster. Client basically creates a program, compiles the program, it constructs the data flow graph, it passes the job to the job manager, and finally when the job is completed it retrieves the result also. Job manager, it receives the job from the client and it computes the execution graph, it assigns or deploys the task to the task manager, it supervises the task manager when the task manager is executing the job. That is the role of the job manager. Then next we have is task manager. So task managers are actually responsible for executing all the assigned tasks, and they run the task in separate slots as per the specification, and whenever task is getting completed or some errors are coming in, it keeps on updating the status to the job manager. This is what is the responsibility of task manager. Let us talk about few more terminologies which are about APIs. So these are not only terminologies, I will say these are the benefits which we are getting. So the kind of benefits we are getting, so you can see that it has got APIs for Java, Python and Scala. Java and Scala are more mature because they have been from the beginning, but Python added on later and then the capability got evolved. So it has APIs for both Java, Python and Scala. Then we have high level operators, because as a data engineer, as a analyst, you need so many operators so that your query, your script becomes smooth and easy for you to develop. So it has got high level operators. Low latency, the response time is quick, it is fault tolerant, one of the node is down, it won't affect the performance of the cluster. Scalable, 1000 plus nodes cluster we can create for Apache Flink. It also has got the capacity to process graph data, ML data, and also complex event processing. Now, basically, we will move towards other features of Apache Flink. I hope till this point you were able to enjoy and keep up the enthusiasm. I hope you liked the Flink series videos, and if you have any kind of queries or questions, please do write us in the comment section below. And try to share this video to as many as possible. And if you haven't subscribed to our channel, please subscribe.